So this video is just a follow on with the Harrier CBX. When I did it on the air test, I realised the green green light bulb for the receive was too dim. Now the LED which the customer had put in himself was too bright. So what I've done here, we have got a Harrier CBX which I've never looked at, and we'll do this as it's been labelled by Mark and it doesn't work. So what I'm hoping is to plug this in, and I'm hoping the green light to work so we know what intensity it should be, because I don't see these with working green lights. So we'll power this one up. Ah yes, there we go. Now we know what it should look like. Good. They're knobs off a Denita, aren't they? Or have they just had those arrows put on? Yeah, they're just stuck on. So it's not as bright as the transmit one. I'm not going to put it into transmit. Yes, I am. I'll just connect it up to the test set. So I'll just pop it into transmit. Borrow the mic from the other. Yeah, the red is brighter. The red is brighter. Whether or not it comes through like that on the video is another thing. So I'll put that on the floor. Right, so these radios have got a dropper resistor. What I'm going to do, I'll go through the analysis of this with you, and you'll see how we come to a conclusion. So I'm going to get a circuit diagram, and I'll try and blow up the bit where it's just where the bulb is. Right, so we're going to do some maths. So I've checked how many ohms the bulbs are. The catalogue says the bulbs I use are 80 milliamps at 12 volts. So these radios, of course, are 13.8, so we need to. That's why there's a dropper resistor. Otherwise, it'd be like a headlight and then burn out. So those bulbs which I've fit are 80 milliamps. So what we need to know is what are the bulbs that they fitted. Well, I'm going to assume, seeing as I'm not taking mine apart today, that the red bulb, which is already in, is the same number of milliamps as the green one. So if we unsolder, I've just traced the wires through, the red wire and the white wire are what it is. So if we disconnect that wire as a temporary measure, we can put our meter across it. See how many ohms it is. Which is 20. I'll tell you what, I'll use the other meter, because this is what I used for the new bulb. So the bulbs I'm putting in are 15 ohms. Well, it read 14.9 on there. So I is current equals V over R, says Ohm's law. So the volts is 12, over 20. I could probably do that in my head. And that other one works out at 80 milliamps. So 12 divided by 20 60 milliamps. So therefore the resistor is going to be wrong. So at the moment I'll just look at whether it's come off the printer. Yeah. Meter bulb, receive, transmit, 270 ohms. Now receive gets its thingy from this transistor, which is also 270 ohms. So 270 for transmit, 270 for receive. So let's see what happens. Because they've set a brightness, haven't they? They've set a particular brightness. So if you're having it at full brightness with that bulb, we need to lose 1.8 volts. So lose 1.8 volts. So it's going to be R equals V over I. So it's going to be 1.8 divided by 0.6. So 1.8 divided by 0.6. Well, if it was full whack, it'd be 3 ohms at full brightness. So, you know, this is why you've got to do other things. It's all right being in a laboratory, which we're not. We're in a workshop, and and working these things out. But I've got a way of doing this. We'll use a decade box. I'm going to take the camera back to where it should be. And full brightness we know would be, or with our bulb, we'll just change the maths round. So now it's going to be losing 1.8 volts, 1.8 divided by actually no, it's that was flawed. Error, it's 0.06, isn't it? 0.06. So 1.8 divided by 0.06 is 166 ohms. That's more like it. So as they have it, it's 166 ohms. As we have it, because we're losing 1.8 volts, the difference between 12 and 13.8 volts, and ours is 0.08. So it's now 1.8 divided by 0.08. So be 22.5 ohms. Quite a difference. So they've got 270 ohms because they're not having it at full brightness. So what we'll do, we'll set up this decade resistance box, and we're going to set it up for what? 22 ohms? Right, so we've hooked it up to the decade box, which is here, and it's lit up like a Christmas tree because that's too bright. So if I go into transmit, there's the transmit one, there's the receive one, which is too bright. So we've done by the maths that 22 ohms would be the full brightness of this bulb. So we don't want it full brightness, we want it dimmer than that, and not as dimmer as it was on the 270 ohm resistor. So very quickly we want more. Tell you what, we'll start by putting what we got in. We'll put in 30. That's 32 ohms. Let's go into transmit. You know what? That's probably about where it wants to be. Transmit, receive. If we put 40 ohms in, well, I don't know. Try 100. The dimmer we have it, the longer the bulb lasts, and we don't want the bulb holder to melt. You know what? I think that's the safest, 100. Now if we go from there, we did 200, we're back to where it was. You see, that's 200, well, that'd be 270. So I put 270 in, which is where it was. So as I had it originally, it was there. So let's go back to 100. 100 is there. So let's put 120 in. 110, 120, 130, 40, 150. Is that bright enough? No, I think we'll go back a bit. I think 100's our best compromise between having a bulb that gets hot and melts the holder and it being the right kind of brightness. So I'll get a 100 ohm resistor. Now it needs to be half a watt. So the ordinary quarter watt resistors that you would normally use in electronics aren't suitable. So that's what's come out, remember. It's a cement one. We've got some industrial grade ones which are 0.6 watts. So obviously more than half a watt. So we'll turn that off and we'll swap that resistor before your very eyes. But you can see what a faff this is. I hadn't realised that these lamps, as factory fitted, were 60 milliamps. We've had to find a set with a working lamp to be able to find that out. And of course we can't get those, as you can well imagine. Right, I'll go and get a resistor, 100 ohms. There we are. It's only the size of a standard resistor. These are German, but it's 0.6 watts. It's 1% tolerance. So we'll pop that into the radio. To just make sure that we haven't got any solder stuck in any holes. Yep, it goes in alright from that side. Now I've got to try and weave it in from this side, and we're going to mount it just away from the board, not dead close to the board, because it will get warm, just like the original one would have done. Right, we'll power it back up. And there we have the green light where we've set that resistor to 100 ohms instead of 270 into transmit, back into receive. So not so bright as it works as a headlight and melts the holder, and not so dim as it was that it was hardly discernible. So that's that. The other thing I'll just mention, I noticed this mic's a little bassier than the ones which we buy. So I'm just going to switch the radio back into PA like we did yesterday. And let's just key it up in PA. Testing. I've gone and plugged the wrong speaker in. That's the test equipment speaker. This is the one mounted on the wall speaker. Testing 1 2 3 4 5 5 4 3 2 1. I'm just going to swap it for our and I won't be able to get these either. Oh, I can get those. Hang on a minute. What have we got? It's not the same one. I've only got about 5 of these left, and then that's the end of it. Testing 1 2 3 4 5 5 4 3 2 1. They're a little bit more trebly, so that's another point. The inserts differ from mic to mic. I mean, that's absolutely fine. Right, so there we are. Back to CB, and we have it the brightness you would expect. We'll get the set back together and get the set back to the customer. I've got a Thunderpole 3000. I don't do CBs on a Sunday normally, but with the organ job and all that, I just had to get this finished. And I'm going to do a Thunderpole 3000 not on video, because I've done about 5 of them. You know what I'm doing. I'm optimising it for UK only. But what I will be doing is the on-the-air test. So you're going to see the on-the-air test pop up. Now the customer has bought this, no doubt from Thunderpole themselves, as a kit, as in with an aerial provided. So he's got a centre-loaded shortened mag mount, and he's a business user, as in I think he's a taxi. Oh no, he's not. He's private hire. There's a difference, and he wants it just to listen to road conditions on those kind of roads where you know it can happen. So he knows that the Wallis can be on 19. And so I'm going to SWR is aerial, which has come centered in the middle of the 80 channels, where he's not going to be using 80 channels, he's going to be using 40. So the SWR on channel 19, channel 20 of UK is more than 2.5 to 1. Now the aerial will do 1.3 to 1 on just lower than channel 1 of UK and just higher than channel 40 of CPT. So it will do 1.3 to 1. So what I want to do is to kind of shift that SWR to be about 1.5 or better on channel 20 of the UK set of channels for him. So what we're going to do is we're going to go out and test the radio as we normally do, and then I'm going to get Mr. Chippy to swap aerials over, which is a bit of a job in the test car, and I want him to do the test again with the customer's mag mount. Then I'll tell the customer to have a look at the video, and we'll see what the performance difference is between our drilled into the body aerial, which is it's a copy of a modulator. It's a Red Thunder, I think it's called, or Red something anyway. I've shown it a million times. They're relatively cheap, they're about £15. And then we're going to compare that with the customer's mag mount. You see, that's the plan. So go out, do the test with his set on this bench, and our area, and you know everything is normal on the test car, and then get Mr. Chippy to come back here and swap it, the aerial, just the aerial, for the customer's one. So that's going to make an interesting test. He says the aerial I got with the aerial with the radio, you know, I looked at him gone out. You know, I wasn't expecting radios to come with aerials. So I'll just put this together. Bob's your uncle. Just make sure it still works. So it's all in Ohm's law one way or the other. Power that back up. There we are with the receive light. That's what you'd expect. So hopefully there's a little bit of help there for people who've got bulbs in sets. Now you can't put an LED in some of these. It affects the circuit like this one did. When he fitted the green LED, A, it was too bright, and B, it affected the electronics with it being switched with a transistor there. It was, or the biasing would be wrong. So we've gone back to a bulb, which is what it should be. I must send him his LED back as well. So that's what that's about. But you may come up against this kind of situation where you've got to use a different number of milliamps. So let's be clear, it was 60 milliamps came out of this. The only bulbs we can get are 80 milliamps. So that's what's all about. So thanks for watching the Harrier CBX Revisited, getting the receiver light the right brightness.